Good morning. This is a video on rotational symmetry, the angle of rotation, and how to rotate shapes and figure out where they're going to land if you have them on a graph. To start off, I want to talk about what rotational symmetry means and how we can start to apply some numbers to it. So on the Class 1 notebook, there's a link here that can take you to a great place to play around. It's on a website called GeoGebra to get the ideas and start to feel with some of this. And so I have it open over here, because the first thing that I want to talk about is rotational symmetry, and if an object has rotational symmetry and what that means to have rotational symmetry. For this example, we're going to be looking about rotating objects about the center, because that's how we determine if it has rotational symmetry. If we look at this square, looks like a plaid quilt or something, an object has rotational symmetry if you can spin it around and it looks exactly like itself before you've gone all the way around. So if we look at this shape here, if we start spinning it around, we haven't gone all the way around, but already the shape looks the exact same. And we can actually continue, and this one does more than once. So we can continue going around and our shape looks the exact same. So this shape has rotational symmetry. And we say that this shape has a, let me just get the word right, it has rotational symmetry, and we can be more specific, saying it has an order of rotation, and the order of rotation says how much rotational symmetry an object has. So the order of rotation is going to be how many times it looked the same before we got back to where we started. So we started like this. If we go all the way around, we got 1, 2, 3, 4 times it looked the exact same. So order of rotation is the number of times it looked the exact same as you spun it all the way around once. So the order of rotation for this shape would be 4. So if we go back to our notes, the order of rotation is the number of times a shape looks the same when spun around its middle. So let's look at another example. So if we go to, let's go to 8. For this shape, does this shape have rotational symmetry? It looks like it does. So to confirm, we can spin it around and say like, yep, it looks the exact same before we went all the way around. So already we can say it does have rotational symmetry. If we wanted to know the order of rotational symmetry, we need to count how many times it looks the same before we get all the way around. Some people may be able to visualize it just by looking at it. Some people may need to practice with this tool to get there. 1, 2, 3. So this shape would have an order of rotational symmetry of 3. Let's go to number 2. This shape here. Does this shape have any rotational symmetry? Well, let's find out by spinning it. So it doesn't look the same until we get all the way around. So this shape does not have rotational symmetry. We don't say it has an order of rotation of 1, even though it looked once the same. We just say it doesn't have rotational symmetry. It has to be 2 or higher to say it has rotational symmetry. And the last thing that we can talk about, so if we go to number 10 here, does this shape have rotational symmetry? It looks like it does. And if we start spinning it, oh, already it does. 1, 2, 3, 4, 5. This one's going to have a lot. We can count up the points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 points. So this shape would have a order of rotation of 18. The last thing that we can talk about when talking about rotation is if you have a shape that has rotational symmetry, it's useful to know what the angle is until it matches up to be the same. So for this shape, it's 20, and then 40, and then 60, and then 80. So we can tell that this shape is matching up exactly the same every 20 degrees. If we go back to our first shape, this one is matching up at 90, 180, 270. So this one is matching up every 90 degrees. How can we find that angle? It's related to the order of rotation. If we want to find the angle of rotational symmetry, so the angle, it is always in equal parts with rotational symmetry. So what we do is we take 360, our full circle, and we divide it by our order of rotation. So if we ever want to find what that angle is, how much I need to rotate a shape, so if we look at this example, how much do I have to rotate this one in order for it to be a match up, and how much does it line up? What is its angle of rotation? We take its order of symmetry, which in this case was 3, and we go 360 divided by 3. So if we just do it in red, (360) divided by 3 is going to be 120 degrees. This is an example. Let's test. If we put this one quickly to 120, it does match up. And if we wanted to find the next one, 120 plus 120 is 240. And sure enough, that is the second point of symmetry. The second point of symmetry works. Good. The last thing I wanted to talk about is rotating an image on a graph about a point. So this is not looking for rotational symmetry. This object, we're not concerned about it. We're taking it if we have it, and we want to rotate it about point A. Okay, so for this example, we want to rotate 90 degrees clockwise, sometimes written as CW. Just in case you're unsure, clockwise is this way, and then the opposite of clockwise is counterclockwise, sometimes written as CCW. That's going to be going that way. So if we wanted to rotate this 90 degrees clockwise, just like we did with line reflections on a graph, we want to do it 1 point at a time. We want to rotate them 1 point at a time. So if I ignore all the other points and we just look at M, M is right here from A. If we think about it being hinged or on a string, and we were to pull it around 90 degrees clockwise, so we're going this way, 1/4 of a turn. So it's going to this way all the way around, 1/4 of a turn. It's going to swing it around to here. So this is where our M prime is going to be. Now if we take S, S is 2 away on the same line. So if we swing it around, it's still going to be 2 away from A. So the distance from your point will always remain the same as you rotate something. And here we have S prime, and we can make our first line. R is down 3 and over 1. So when it rotates over here, it's now over 3 and up 1. So the dimensions of 3 and 1 remain the same. So we could go through. Next we have M, which is over here. N is going to rotate right here. So N prime. And now as we start to get our picture, we may be able to see it filled in. Point Q is 2 down from A. So it's going to end up right here. O is 1, 2 over this way. It's going to swing 1, 2. O prime. Then our last point P, I'm going to fill in right here. So I'm going to grab a new color just so we can see the shape a little bit better. We end up with the shape landing just over here after it was rotated 90 degrees clockwise. The rotation information and lesson on Cyber School is quite good, so that's why I was okay to just do one example here. The rotational symmetry and the order of rotation I felt needed a bit more fleshing out, so that's why we went through more detail there. If you have any questions, please send me a message.